Hi, this is Alex from devstories.eu. PySpark Fundamentals, episode 13 of 21. You have a team of analysts who write excellent SQL, but your data sits on a massive distributed cluster. You could force them to learn a completely new Python syntax, or you could let them unleash the language they already know. That is where running raw SQL strings directly in PySpark comes in, bringing old SQL new tricks. PySpark gives you a direct bridge to standard SQL through a single method on your Spark session called simply SQL. You pass a raw SQL string into this method. The output is not plain text, it is a standard PySpark DataFrame. This means you can run a standard database query, get a data frame back, it immediately pass it to another Python function. It is entirely interoperable. Before you can query data with SQL, PySpark needs to know what tables exist. You have two main ways to expose your data to the SQL engine. First, if you already have a data frame in Python, you can call a method to register it as a temporary view. You give it a string name, and suddenly it acts like a table in your SQL queries. Second, you can create tables entirely within your SQL string. You pass a create table statement into the SQL method. Inside that string, you define the schema and tell PySpark exactly where the underlying data files live, such as a cloud storage path containing Parquet files. PySpark registers this in its internal catalog. From then on, you query it by name, just like a traditional database table. Compare how the same logic looks in both approaches. Say you need to grab customer names, drop anyone with a zero balance, and merge the result with an orders table. In the DataFrame API, you build a chain of Python methods. You call select on your customer dataset to pick the name column. Then you chain a filter method, checking if the balance is greater than 0. Finally, you append a join method referencing the orders dataset on a matching key. It is highly programmatic. In the SQL approach, you write a standard select statement pulling the name column, add a where clause for the balance, and write an inner join for the orders table. It sits in your script as a single readable string block. Here is the key insight. There is a common misconception that writing SQL inside Python strings must be slower or less native than using the structured data frame methods. That is false. Whether you chain Python methods or pass a raw SQL string, PySpark treats them identically. Both inputs are immediately parsed, translated into the very same logical plan, and handed off to the Catalyst optimizer. The execution engine does not know or care which API you used to express your intent. The performance is exactly the same. The choice between the DataFrame API and raw SQL is never about cluster performance. It is purely about what makes your team faster and your codebase easier to maintain. Thanks for hanging out. Hope you picked up something new.